Unit 6, Lesson 6, Orbital Diagrams. Orbital diagrams explain how electrons are arranged within the atom. They show the order in which electrons are placed in the orbits. We will use boxes to represent individual orbits. We'll use different colors to represent sublevels such as S, P, and D. Here is the orbital diagram. You will notice that it has increasing energy. And we will start all the S orbitals, remember these are our spheres, are all going to be in yellow. The P orbitals, which are the ones that look like the dumbbells, are in green, and our D orbitals will be represented in this reddish orange color. Here is the exact same thing, just shown all with the lines attached here to the energy to remove the confusing arrows. As the number of electrons increases, so does the repulsion between them. Therefore, in many electron atoms, orbitals on the same energy level are no longer degenerate. In other words, they will not occupy the same place at the same time. To place electrons in orbital diagrams, electrons are represented by arrows, and the direction of the arrow is used to represent the electron spin. The spin of electron has only two allowed values, either a plus half or a minus half. We're going to look at them in regards to just arrows, one pointing up, as shown here, and one pointing down. The Pauli exclusion principle states that no two electrons in the same atom can have the exact same energy level. So for example, no two electrons in the same atom can be in the exact same place at the same time. Makes sense. Hund's rule states that the electron must occupy the lowest energy and have opposite spins. So as we start out, 1s, 1 being smaller than 2, 1 is our first orbital we will fill, and we will place two electrons in there, and you will notice that they both have opposite spins, one pointing up and one pointing down. Here's the orbital diagram again. So let's look at hydrogen and helium. The 1s is written first, so here's our box with 1s. It is the lowest energy level. Helium has 2 electrons and hydrogen has 1 electron. Since they must occupy the lowest level first, hydrogen, we will place our 1 electron here in the 1s in the up position. Helium has 2 electrons, therefore they will both go into the 1s, but one will be placed pointing up and the other will be placed pointing down. Orbitals can hold a maximum of 2 electrons. Within the sublevels that contain multiple orbitals, 1 electron is placed in each orbital with parallel spins before the electrons are paired. So here with the 2s as well with the 1s, we can place 2 electrons in each orbital. Now when we get to the 2p, and p can have 3 orbitals for a maximum of 6 electrons. Rather than pairing the electrons up originally, they will place 1 in each orbital until each orbital has at least 1 electron. Then we will go back and add the other electrons in the opposite direction. So here's an example of where as we go, you will notice we just add 1 more electron in the opposite direction. When we get to the p orbitals, we will just add the extra one, but in the same direction, but in the orbital next door. Here's the guide. First, you'll draw boxes to represent the occupied orbitals. We will then place a pair of electrons with opposite spins in each filled orbital. We will then place the remaining electrons in the last occupied sublevel in separate orbitals. If you feel confused at this time, it is perfectly normal and you will get better with practice. So the first thing we will do is to draw boxes to represent the occupied orbitals. We will then place a pair of electrons in the last occupied sublevel in each separate orbitals. We place the remaining electrons in the 2s orbital. We will then place the remaining electrons with opposite spins in each filled orbital. First, we will pair of electrons with opposite spins in the 2p orbitals with the arrows in the same direction. So we will practice, and with the practice, we will start on another slide.